All right, welcome to the second part of our statistics week. We're going to talk about normal distribution in this video, which is probably my favorite bit of this whole week. I think it's rather neat. So anyway, let's get into it. So normal distribution, when someone says that this data is normally distributed or is shaped as normal distribution, this is what they're talking about. It's a bell curve. That's what we call it. And the bell curve is a very specific bell curve. And these values are the same for all normal distributions. It's not like totally random. I have a little bit kind of an illustration here on the right that's going to just kind of remind me of all these values that we're going to list here. But I'm going to do my best to just explain it all from the beginning. So you can see I've got a blank bell curve on the left, and I'm going to annotate this and sort of walk you through how it's laid out. And it's your goal to memorize this bell curve, especially the percentages. So right in the middle, simple enough, this is our mean. So if this was, we'll make up numbers later, but this is our mean. We'll call it X bar, right? We mentioned that earlier. Actually, you'll see there's another way to call mean. They use what's called a mu, which is another Greek letter. So X bar is mean, mu, which is the letter you kind of see here. That is also, it's kind of like a U with a squiggle on the left side. I don't know, it's weird. But that also means mean. Means mean. Anyway, that's the mean right in the middle. And each of these tick marks that you see going out, this is not just a number line. This is a standard deviation. So this will be noted as one standard deviation away. So we're going to use that little symbol we used before. So one standard deviation away. The second tick mark means two standard deviations away. Then the third tick mark means 3 standard deviations away. And it's the same thing on the left side as well. It's just in the opposite direction. So 1 standard deviation away onto the left side. Now there are 2 standard deviations away on the left side, and then 3 standard deviations away. Okay, I know it kind of looks like 10, 20, 30, but that really means 1 standard deviation, 2 standard deviation, and 3 standard deviation, as I mentioned earlier. Let me see, can I change my color real quick? Let's go with blue. So that's sort of the number line aspect. Right in the middle, at the peak, is the mean, which is the center. And then each little tick mark that you see me right here is a standard deviation. So 1 standard deviation, 2 standard deviations, 3 standard deviations in both directions, the left and right. Now, this middle region, which goes from 1 standard deviation to the left all the way to 1 standard deviation to the right, which means, quote unquote, within 1 standard deviation. So I'm going to say within 1, I'll just abbreviate it SD for standard deviation. Within 1 standard deviation, so that could be to the left or right. It's kind of like saying, I'm going to leave in an hour, give or take 5 minutes, right? So you could leave in an hour and 5 minutes, or you could leave in 55 minutes. So that's kind of what this is sort of like, right? If an hour was like the mean, 1 standard deviation is going to be like 5 minutes later. Another standard deviation would be like 5 minutes earlier. So it's within that range. So within 1 standard deviation, this is 68% of our data. 68%. And if you want to be really specific, it's 68.2. You can kind of see the side on the left breaks it up, and if you add them together, you get 68.2. But we're going to say that together it's 68%, which makes, just the left side 34% and the right side 34%. But together, the whole region in the middle is 68%. Now, within 2 standard deviations, so within 2 standard deviations, so we're going to go out another branch. I'll just keep it blue. So 2 standard deviations. So now we're talking about, well, I kind of do want to change a different color. Make it easier for me to explain. We'll go with purple. So it's 2 standard deviations. So that adds on another Well, it says 13.6 on the slide, but I think 13.5 is more like a general thing. So another 13.5% this way, and another 13.5% this way, which together, if you add up the 68% that we have there and the now 27% that we just added on, because 13.5 here and 13.5 here makes 27% altogether, within this whole region, so from two standard deviations below to two standard deviations above, this whole region of my bell curve is 95% of all data points. 95% of all my data falls within two standard deviations. And then lastly, 3 deviations away, so we're going to go with green, I guess. 3 standard deviations. This adds on, oh, I'm forgetting the number. 2.35%, which is tricky. 2.35% here on the left and another 2.35% on the right. So that's just this part and this part. That's 2.35%. Together, though, from 3 standard deviations below all the way up to 3 standard deviations above, this is 99.7% of all my data. You can see that we basically used up the entire bell curve. There's only a really small marginal part on the ends that's not within my data point. But 99.7% of this area is between 3 standard deviations below to 3 standard deviations above. So within 3 standard deviations is 99.7%. So this information right here, these percentages never change. They might seem like they're random, but they're not. If you have a normal distribution, then 68% of all your data is within 1 standard deviation from the mean. 95% of your data is within 2 standard deviations of your mean. And then 99.7% of your data is within 3 standard deviations from your mean. So that's general, numbers to memorize, bell curve for normal distribution. But let me explain this in context of some sort of real world problem to help you kind of get an idea of everything we've just talked about. So let's say I go out and I measure, we'll say, let me think of something. Let's say I measure the weight of fish in a lake or something, okay? And let's say I have all my data. I've gone out and I've weighed a bunch of fish, okay? It could be like 100 fish, it could be 1,000 fish, whatever. But I've gone out and I've weighed all this fish, right? And I found that the mean was 10 pounds. So the average was 10 pounds, right? And let's say that the standard deviation of my data set is 2. So we're going to pretend the mean is 10 and the standard deviation is 2. So if the standard deviation is 2, then 1 standard deviation would be at 12 and the 1 standard deviation below would be at 8 because that's 2 less and that's 2 above. So 1 standard deviation less than 10 and then 1 standard deviation more than 10. So that's the mean plus 1 standard deviation, which is 2, and then minus 1 standard deviation. 1 standard deviation, which again would be minus 2. So if my standard deviation is 2, then that's where those data points would lie. All right, which would make 2 standard deviations at 14 and 6, and then would make 3 standard deviations at 16 and 4. As far as the pounds of the fish, if my mean was 10 and my standard deviation was 2. So this would mean that 68% of the fish in the lake are between 8 to 12 pounds. If I go out and I look at my data, 68% of the fish that I caught would be between 8 and 12 pounds because they fall within 1 standard deviation. Now, if I talk about within 2 standard deviations, which is between all the way from 6 pounds to 14 pounds, that would be 95% of my fish. 95% of the fish that I caught in the lake would be between 6 and 14 pounds. And if I wanted to go 1 standard deviation further from 4 pounds to 16 pounds, that would be 99.7% of my fish. So 99.7% of the fish that I caught are between 4 and 16 pounds. If this was the data I had discovered, if my mean was 10 and my standard deviation was 2. Okay. So sometimes they ask weird questions on the EOC like, what's the percent of fish that weigh more than 10 pounds? Well, the percent of fish that weigh more than 10 pounds, because 10 is the middle and more would be this side, that would be 50%, because that's obviously half of them would weigh more than 10 and the other half would weigh less than 10 if 10 is your mean, right? So they ask kind of funny questions like that. But most of the time they ask, what percent of fish are between 8 and 12 pounds? In that case, it'd be 68%, because 8 and 12 is 1 standard deviation. And from 1 standard deviation to another, that is 68% of the data. Again, these are just numbers that you would have to know and memorize. Okay? So I hope that explains it a little bit. All right. So Kelly collected the heights in inches of 20 females. She wants to identify the minimum and maximum heights for 68%, 95%, and 99.7% of females based on her sample. So these numbers will look familiar because this is referring to, the 68% is referring to within 1 standard deviation. The 95% is referring to within 2 standard deviation, and the 99.7 is within 3 standard deviations. So this is kind of our clue that we're looking at the values for the 1 standard deviation, 2 standard deviations to 3 standard deviations. So we've got our set of data, right? It's listed out, 65, 67, 68, 64, etc. So the first thing we want to do is, of course, what is the mean and what is the standard deviation of this data? So we're just going to type this in the calculator and get that real quick. So let me go open my calculator and type these all in. Let me change the view a little bit. You can skip ahead a bit in the video if you want to just skip me doing this part. Okay. It's kind of tricky with, having 20 points of data put in there, because it's kind of easy to think that maybe you skipped one. But I'm looking at my list right now, and you can see that 63, if you look closely, let me make this a little bit bigger. It says L120, so you see that 20 parentheses? That's the 20th value I entered was 63. And I know, because it says right here, that there are 20 females that I measured. So if I have 20 values input in my calculator, as I do here, because 63 is my last one and it's my 20th one, that makes me feel kind of good that I inputted them all. Because if I have 20 values in my calculator and there's 20 values I was supposed to type in, then I feel good. But if I have 21 in my calculator, I'm like, okay, which one did I count twice? Or if I have 19 in my calculator, I'm like, okay, which one did I miss? So just something to kind of keep an eye out for. We're going to go to stat, we're going to go to calc, one var stats, and we are going to get our mean, which is 65, and our standard deviation, which is 3 we'll just say 3, because that's probably good enough. I don't know if it says anything about rounding. It does not. We're going to say the standard deviation is 3, though. So let's go back to this. So what does our mean? 65? Yeah, okay. So our mean is 65, and our standard deviation is 3. So if we think about a bell curve here, it's probably better if we kind of make that illustration. Our mean in the middle is 65. And then one standard deviation is 3. So one standard deviation to the left and to the right. So if we subtract 3 and we add 3, we'll have one standard deviation. So 62 will be one standard deviation below, and then 68 would be one standard deviation above because we're adding 3 to the mean. If we add 3 again, we'll get 2 standard deviations. So it would be 71 on this side, and 62 minus 3 would be 59 on this side. And then we want one more standard deviation, we take another 3. So 74 and 56. So we identify the mean standard deviation. I just did that. The mean was 65 and the standard deviation was 3. Find the lower and upper bound for 68%. So because I just drew my bell curve, this makes it easier. So one standard deviation was 62 to 68. That's my 68%. My 68% is between 62 and 68. So I'm going to write that as an interval. So it says identify the lower and upper bound. So the lower bound will be 62 because that's 3 less than 65, and 68, which is 3 more than 65, and 3 is that one standard deviation. So for the 95%, that's for the second standard deviation. So the second standard deviation was that from 59 to 71. So 59 to 71. These are not ordered pairs that I'm writing, by the way. This is an interval saying from 59 to 71. And for the 99.7, that's the third standard deviation. So that's the 56 to the 74. So 56 to 74. All right. So again, what that's saying is that for the heights of females, 68% of the females are between 62 and 68 inches. 95% of the females are within 59 and 71 inches, and 99.7% of the females is between 56 and 74 inches. All right, I'm going to end it there. We don't need to do these other examples. They basically are replicating the same exact thing we just did. So hopefully, if you just, need to rewatch it, you can. But hopefully you can handle these. I'm going to end it here. The next video will be about set notation.